Hello, I'm William. I been working on building this clock, and I've got a process that I like to go through for crossing out my wheels and how I machine all that. I wanted to just show you guys how I do that. Maybe I'll give you some good ideas. So this is my process. I want to mention that another fella on YouTube has put out a video on using a pantograph. He uses a Priest pantograph. His name is James Lay. Check his channel out. He's got a bunch of good information on there. It's fantastic when you get these gentlemen showing their process on something that they do, and they show it to us for free. So give him a thumbs up. Put some nice comments on his videos. Check it out. Anyway, I just wanted to kind of add to what he was doing because I'm doing it just a little bit different. So put some ideas together and maybe it'll work good for you. This is a Gorton two-dimensional pantograph. It's the model 3-U. Online, I found an ebook that has the instruction manual for this pantograph and for a bunch of other of the Gorton pantographs. So if you have one and you need the instruction manual, it's got good information in there on reduction ratios, measurements that you would use, so on about these Gorton pantographs. I'm not sure about the other brand names. I'm sure there's potentially some good information out there too. Okay, like I said, it's two-dimensional. It has a table for tracing up here. It's like a regular knee. For a milling machine, it has X, Y, and Z. This has a lever here that drops the spindle head down into the workpiece, or when you lock it in there, you're cutting your finish, you can pull that up if you need to move into a different spot. Down here we'll see spindle speeds. Now it's recommended for brass to get up between 10 and 15,000 RPM. I'm going to be running at 9,000, 9,600 or so. Pulley system here, rope pulleys to the spindle head, one that goes back and down to the motor. This machine, I brought it home. I had it on my trailer and I used a come along to pick it up, and it almost came down on top of me. Lucky enough for me, something was telling me to get out of the way, so I was above it instead of below it, and I ended up dropping it, and you can see the different color paint there, and it cracked the corner of this cast off. Shouldn't have used it. Lesson learned. So if you guys are moving any kind of machinery, this weighs about 700, somewheres in there. Moving any kind of machinery, be careful. You'll hurt yourself. Mine here, I don't know if we'll see it or not without the light being right, but there's numbers along here. Okay, 1 through 8. There's numbers on this upper arm. You can see those. Okay, and that's for reference for where that block gets set and where that block gets set. Now, there's also numbers on this piece here. You might not see those, but this ram here can move in and out. Now, if you're doing a straight up 2-to-1 reduction or 3-to-1 or 4-to-1, whatever, then you can put those numbers, should all be on the same number, and that'll give you that reduction ratio. But if you have a special reduction, and this is my plan here and how I'm going about this, is
this one template is going to cut out any different size wheel that I need, or cross it out. So I need to know how to reduce differently than just a straight up 4-to-1 reduction or whatever. Otherwise I'm making a bunch of different templates. So the ebook that I mentioned has reduction ratios for all different sizes. Basically taking the diameter of my template and dividing into it the diameter of the workpiece that I want, or the piece that I want. Now there's a little bit of play here because you have your cutting bit and you have your stylus. And you can change the diameter of your stylus to change the size of your end product. Now looking in here, I've got a bunch of little sleeves that are different overall diameters, and then this will just slip. That's all magnetic. I don't know if I'm liking that, but anyway, this will slip into here like so. And then when I trace it, now when I trace these, I'm going to be doing it like this. I'm going to take that off, then I'm going to use the smaller diameter, and then I'm going to flip it over and use this diameter to trace, and that'll give me my clean off cut. Turns out nice that way. To make sure I'm proper in the dimension that I want down here, we can be a little forgiving. What I did is I took the diameter of my smallest wheel that I'm going to be making, drew it out on my drafting board with the design, stuck the piece of paper in the printer, scanned it to my computer, and then increased the size. And just doing it that way gave me a quick way of making sure these dimensions were right, so that these spokes, and I had made a couple other templates and it wasn't working out right. These spokes, if I had this any narrower, I'd be cutting away the spokes after I did a reduction on it. So this can be any size.
That's the machine. Some basic ideas about it and how it functions. Anyway, let's get to work.
All right, over here at the workbench, what I have here is a piece of C353 engraver's brass, drilled and reamed a 1/4 inch hole. Before drilling that hole, I can quickly mark and get center. Getting center isn't critical. Now this is an oversized piece of brass. As long as I don't run out of room in my outside diameter wheel blank, I'm okay. That can be kind of anywhere, so it's not critical. To drill that and ream that hole is, though, you want a nice smooth round hole. Now I've made these, by the way, this is just a needle that I use to draw stuff with. Now when we zoom in here a little bit, you'll see this piece is a little center. In the lathe, just took a piece of 1/4 inch stock, drilled a center in there, put a little taper in it, and my little pin that I was talking about fits in there and kind of locks in. So when I'm setting this up, I'm going to use a piece of masonite. I'm going to have that sitting on my table, and then in the head, in the spindle, this pin will be in the spindle, and I'll just drop it down till it gets tight. Make sure that's right in there, and I'm going to lock it into place. what I want to do here is draw out approximately the size of my crossing. So we'll get that done. Let's see. You guys can't even see that. Where the heck is that camera? Oh boy. Ends up to this inner ring is where I want my crossing to be. I'm going to cross the spokes out to that point, approximately. Okay? Okay, to get my reduction size, I take my template size, which is 6.759 inches, and then my workpiece size, total, is 2.875. So I'm going to divide 2.875 into this number here, 6.759 divided by 2.875 equals 2.35095565. Okay, whatever. So we're looking here, 2.35. I can go either side of that to round it up or down to 2.4 is my reduction ratio, my reduction ratio. So 2.4. Now I go over here and I look in the book. I'm going to find my lower bar and my upper bar dimension. So at a 2.4 reduction, the lower bar is 1.670. My upper bar is 0.5 from number 2 on my bar. Okay, so my lower bar is going to get changed to 1.67. From number 2. Number 2 is right up here. Right here. Okay. I just moved the RAM up here to get myself on my table. We're going to put our little pointer in. I want to tighten that. Okay. I got my template in an approximate area here that I want it. Run this up. Now by just letting that float, I run that up and it's snug. Put our clamps on. Now up here, all this is locked down. My template just ended up where it ended up. We'll lock that down. And basically, with my pointer, with my stylus all the way to one side of my template, I stick my pointer on there and draw a little line. I want
Now I want to remember the, this is center. This is the middle. It's not the cutter diameter. Now, looking really close without measuring. It's looking pretty close. The other side is the same. Let's trace this side. And we'll trace this side. Now that we're all set, we can begin to trace. There's a little bit of flexing in there you can monkey around with. Diameter of cutting tool, diameter of stylus. That can fine tune your actual size when you're doing stuff like this. Now if you're setting it up to write letters, it's probably a little more straightforward. But we got a little flexibility here with how we're doing this. Okay, we're using a 2-flute 1/8 inch diameter bit. I have some single flute bits. They're a little more brittle, seems to me. These work pretty good. Okay, everything's locked down good. I'm liking that. This probably seems like a lot of farting around, but once you're going with it and not worried about filming it, it goes pretty quick. I'm gonna feed the table up. I'm gonna feed the knee up in this initial cut with my cutter all the way down. And once I break through, I can lock my knee in, and then I can manipulate the depth with this here. And I want to put a little oil in this spindle. X and Y are locked. Okay. Take light cuts to start. See, we're not exactly flat. Okay, now take my spacer off
Let's zoom you in. Just like that. That's what we like. Okay. Why I like doing it this way? Well, a couple reasons. One, if my template is accurate, these are going to be accurate. There's no There's no fudge here. It is what it is when you cut it out, and it turns out pretty decent. The other thing is, and I've done this before, I must confess, is after cutting all your wheel teeth, now this is going to be one of the big escape wheels on this clock. After fiddle farting around doing all that, and you start crossing it out, say I was using the pantograph and I slipped and came across one of the spokes, or didn't set it up right, or whatever, then I've wasted a bunch of time cutting all the teeth. This way, I take a blank piece of brass, I cross it out, and if it's acceptable, then I move on to the next portion. Another thing you might say is, well, you know, you've wasted all this material for strength for cutting your wheel teeth. Well, really, I don't know if that's really a big deal, unless you're using something thinner than the 1/16 inch. But the way I do it, and we're going to see all that later, is I'm going to sandwich most of this anyway, okay, with some big washers. Make washers out of aluminum and sandwich that all together. Once that's all sandwiched, at least most of this here on them spokes, I don't think it's moving anywhere anyway. Here's another wheel I've done already. No layout blue on that one, but I do have some lines on there. That's the other nice thing here with our pantograph, is they're going to be identical. Just scaled down into a different size. I like that. It works good.